In Virtual Reality Robot, we enter a virtual world where we can replicate industrial manufacturing techniques. To control the robot, we first need to switch on the control box. We then activate the virtual teach box and switch on the power. We can move the robot in any of the 5 axes using manual control. VR Robot has a number of virtual worlds with tasks designed to teach students control techniques. Here we've programmed the robot to complete a simple task. In later worlds, the tasks and the degree of student interaction become more complex. The teach box is used to store each robot position in memory. We'll set this position as 2. We will now move the robot to a new position and store that as number 3. Next, we'll close the grippers and switch to X-Y-Z mode. Here we'll move up in the vertical axes. The teach box is an exact replica of a Mitsubishi industrial robot control. This provides students with practical hands-on experience of control, while avoiding the problem of classroom bottlenecks caused when using real equipment. However, not only can students use programming to control a virtual robot, they can save their program positions and link these to control a real physical robot. The next task here is to move the robot to a new position over the coloured squares, first storing an intermediate position above, and then another position inside the square. Once the task is successfully completed, the screen lights up. We now have all the positions we need to write a robot program. To enter the commands in the editor, we simply click on a new line, and a menu of commands appear. First we'll set the speed. Then open the grippers, and then move to position 2, ready to pick up the pencil. We then add position 3 and close the grippers around the pencil. We're now going to reuse position 2, but with the grippers closed. And finally, we enter the remaining positions to complete the program. Now we have to switch off the teach box. And click on the Reset task block, the revolving diamond on the screen. And press play to start the program running. Notice how each line is highlighted as the program runs through. We've looked at just one of the worlds within the product. There are others. Each world has a different task, each time getting progressively more difficult. From stacking blocks from a hopper, with other objects for collision detection, to a world integrating a CNC lathe with the robot. We are now entering the Denford full virtual reality sim product. In these worlds, you have total control over many more systems that integrate a complete flexible manufacturing system. There are different configurations, each of which Denford can supply as real setups. Here we see Sim Level 2, comprising a lathe and a mill serviced by one robot on a linear slide. Larger systems incorporate an automatic storage retrieval system, a closed-loop conveyor. In this case, two components are transported on a pallet-based system between the lathe, which turns the components, and the next cell, here the milling machine, which completes the manufacture of the chess pieces. Image inspection for part recognition. An automated guided vehicle to transport components over larger distances, and coordinate measuring machine for quality control purposes. Denford Sim systems are built to be flexible, modular, expandable and affordable. Both software and hardware can be added over a period of time, as courses develop or funding becomes available, allowing a simple manufacturing cell to expand up to a complete sim system.